Let's go.
So the advantage of being the last presentation is that I can just reference all the talks that came before this. I have worked in many startups in my career, and primarily in fintech and enterprise SaaS. And kind of inevitably, we've heard some stories about this already. Inevitably, these startups, companies, as they grow, GRC, the governance, risk, and compliance, it becomes a really key concern for the startup. We heard that a sign that you're enterprise ready is your customers are starting to ask a lot about governance, risk, and compliance. And so inevitably, you start to build features that are trying to address GRC concerns of your customers, primarily big customers. We're talking governments, global enterprises. And in this talk, we're going to talk about one feature that Slack, Airtable, Box, Salesforce, they all built the same feature. You might already know it from the title of the talk. I can tell you what it's not, and it is not on-prem. 10 years ago at a startup, I took an engineering team into a windowless office on Wall Street to deploy in a bank. We're not doing that anymore. It was not fun. We heard, Slack just flat out decided we're not going to build on-prem. And since on-prem is no longer a viable option, it's really forced enterprises to embrace SaaS. If they really want to use the most innovative tools, they need to acquire SaaS products. And we are starting to see, with this kind of change in mindset, some enterprises don't want on-prem. They do not want to go out and figure out how to procure, run, and maintain software in their own systems. They don't want to debug your 20 Docker containers that are all powering your software. So looking quickly at kind of how we got here, and some of the other talks have alluded to this, but rewind before SaaS, and the enterprise network came with a lot of control. These companies had full control over their software, their systems, the network it was running on, and it created this perimeter. We called it a walled garden. Garrett said the castle. But slowly this started to kind of break up. I want to kind of focus on some of the business use cases and kind of the trajectory of SaaS across those. So famously, like Salesforce, it's one of the first to really popularize SaaS. That's a lot of like sales, marketing content. As in 1999, they launched. Then we moved into kind of just file storage, Box, 2005. Started to get into code, but there's also like intellectual property. Certainly the internal communication with customers is now in Slack. And very recently, Notion, which is general productivity, just like general knowledge, is all being moved outside of this area of control into third parties, accessible over a public internet, and largely outside of the control. And the result is not enterprises want to give up control over these types of assets. We've had to find and invent new ways. We've talked a lot about identity and authentication. That's a way that now admins can control these third-party SaaS apps, what users have access to these apps, and the permissions inside those apps that those users can leverage. And they can do that, through their own directory that they still retain control over, using things like SSO and SCIM, FGA. And this is working pretty well. It's nearly real time. You promote someone, you remove someone from the organization. All this identity and access very quickly syncs into these third-party systems. But there's a missing piece here. We're kind of missing one leg of that three-legged stool that's not going to be controlled by IAM directly. And that's data. What's happening to the data? Who's thinking about the data? You know, the enterprises are still thinking about this. They're very worried about this. They don't want to see their data getting leaked or breached or mishandled. And with, you know, their users and their identities moving into these third parties, all this data is moving into it. And while it has kind of gone in the shape of like, okay, we started with sales and marketing, that's kind of like publicly known data. We very quickly moved into very private, very confidential data. Essentially all of these data assets that an enterprise owns. ERP, but also critically customer PII. A lot of that is sitting in Slack and Notion. And enterprises still want to understand, how is my data being handled by these third parties? And so what we've kind of developed to this point is earning trust. Big companies have vendor due diligence processes. If you've ever been on the receiving end of a questionnaire, a security questionnaire, it comes with a spreadsheet and 300 questions in it. You know, there's a very heavy-handed upfront processes. There's also, you know, frameworks and standards that companies can attest to. They can be audited for these, so there can be some validation. But ultimately, this is, you know, creating trust because there's not a mechanism for direct control over how that data is being used in the third party. And for very sophisticated customers, this isn't sufficient anymore. So, you know, I don't think of trust as governance. What we really want is something that is evidence-based, it's tangible, it's irrevocable, and there's a solution that's existed for quite a while that has these properties. It's called encryption. Encryption is better than just trust. It's based on math. It can give you kind of a guarantee that just because someone has access to a piece of data, they can't necessarily use that data or abuse that data unless they have an encryption key to decrypt that data. And so now you have these two tools here where I can encrypt data and understand that it's going to be protected and regardless of where it moves in SaaS's internal systems. And then there's this key that I can give them to use that data if they need to decrypt it and use it to deliver value from their product. So encryption is great, but on its own, it's not quite sufficient to really give those enterprises back control over their data. Why is that? Well, I'll give you an example. Maybe you're going to a restaurant, or maybe you came here today and you drove your car and you're using a valet. So you give them your car, they're going to go park it. You also give them the keys to the car so they can drive it. And you kind of trust that they are just parking that car and they're not going to go on a joyride and enjoy your car. Whoever drove the Ferrari today, check your odometer. You know, what you really want is you want to give away the car, you know, let them go park it in the parking space, but you want to retain some control over that. So this is, you know, Tesla's summon feature, where you still have control over your car through your phone. You can control who's getting in and out of it, and if you need that car back, you just click a button and it drives back to you. And your car is a lot like that enterprise data. It's extremely valuable to the owner. And if there's any damage to it, it's pretty catastrophic. Well, this technology also exists today in the enterprise. And it's called enterprise key management. There's the answer to the question. This goes beyond simple encryption and cryptography to allow a customer to retain control over the data they give to a third-party SaaS. And it works by, similar to how a directory is used for things like SSO and SCIM, the enterprise has a piece of software called a key management system. And this key management system is fully controlled by them, and it is going to generate keys called customer managed keys. The customer is retaining control over the key itself. And then it also provides an interface for the SaaS company to access those keys or use those keys to encrypt and decrypt data. But just like a password, there's typically not one key. That's a bit risky. Certainly if that key were to be exposed, now all your data's at risk. And so what EKMs end up doing is generating lots of keys. And they typically generate keys around kind of organization principles of their own product or their own app. So in the example of the CRM, you might create a key per account or per customer channel. Or in a file sharing product, you might create a key per attachment. It's also pretty typical to generate new keys over time windows. So you don't want a key for all time. You'll generate a key every month or every week. And then when the next week comes, you generate a new key. So you might imagine this is starting to become a lot of keys. And that is true. One of the reasons we need a system outside of the key management system, why we need the EKM, is to just manage all of these keys, hundreds or thousands of keys. If we take a peek inside what an EKM is doing, though, it's not using the customer's key directly to encrypt data. Instead, what it's doing is it's generating a key called a data key, and it encrypts the data key with the customer's key. So why does it do this? Well, one of the things that's really important about using encryption is you don't want to lose the key. If you lose the key, you've essentially lost access to all your data. You're locked out of your data. And so by generating a second key, this data key, and encrypting that data key with the customer's key, then the data key can actually be stored alongside the encrypted file in a database or a data lake or object storage or however. So it lets that it's called an encrypted envelope, keeping the file and the key together in one blob. It keeps that data very portable. You kind of imagine there's not a single database in your backend or your SaaS. You have many databases. Data's kind of moving all over. And so regardless of where this data moves, you're always able to decrypt it back into its original state because the key and the data are together. And decryption kind of looks the same. I have this blob here that has a key and encrypted file in it. So now I can just decrypt the data key with the customer's key and then use that decrypted data key to decrypt the file. So the original file contents are always available. One of the nice aspects of this architecture is that the EKM can be largely stateless. It does not need to store key material. It doesn't need to store the encrypted data. Like I said, if you lose the key, very catastrophic. And so a lot of key management systems that you would get from your cloud provider, like AWS has a KMS service, they have a ton of durability. AWS advertises 11 nines of durability. 9, a lot of nines. Basically, as humanly possible, that key will never get lost. And you can kind of keep that kind of complexity in the KMS. And the EKM can remain relatively stateless. But there's another piece that the EKM can track, and that is the relationships between data and keys. Like, what key should I use for this piece of data? That kind of context is logic that lives inside the EKM. But it's not just that logic. There's a little bit more going on under the hood. You can imagine we're starting to get into the realm of like a lot of overhead here. Decrypting is computationally intense, and so like I'm constantly accessing this data. I'm constantly decrypting keys and decrypting data. That can incur quite a bit of cost. And so it's typical that an EKM will kind of keep a local cache, and it'll keep the data keys decrypted in that cache. So if you have a hot piece of data, something that's being accessed really often, you already have the data key decrypted, and so you can kind of reduce any kind of compute overhead or latency involved in using that data. And you only store the key for a short period of time, and then once that data is not in use anymore, you throw the key away. But as you kind of heard, there's lifecycle management related to these keys, right? We talked about, I want to issue a key on a rotating time window. Or I just want to automate key rotation and allow other functions to trigger a key rotation. So those types of policies will typically be implemented in the EKM. The other piece is that, well, I've got all this encrypted data floating around in my data systems now. How do I let my other tools or software that I'm building decrypt that data to use it? And so an EKM will often provide an API to kind of simplify those types of functions. So I don't now need to code cryptographic libraries and understanding all the context of keys in all my applications. I can just give the envelope to the EKM, ask them, decrypt this for me, and they'll return the payload back. There's a final piece to this kind of entire setup that is really critical. And that is because the KMS is sitting in the enterprise's network or cloud. They can inspect what's going on in their KMS. This is generating logs, like Garrett mentioned, feeding into their log aggregator or into a SIEM. And so they can directly see that the SaaS company is using the KMS the way they attest to. If there was little activity happening in their KMS, that could be a warning flag that their SaaS company is not actually implementing the security controls that they are claiming they are. Or conversely, they can see there's a lot of keys around different granular characteristics being used in my KMS. This is a good indication that the SaaS software is implementing EKM the way you expect it to. And this is completely independent, again, of the SaaS. And so we've really been able to replace this kind of like trust with something that is directly observable and verifiable. And I have some control over my data because I own those keys as well. There's kind of this, catastrophic case where if you're worried that a SaaS provider is potentially having an incident, you can just delete the keys on your side, and that renders any data that they have in their system to be useless. But you also might throw away keys just as part of business process, right? You want to expire data. Data a year old, you don't expect to be useful in that SaaS tool anymore. So again, you can build out that type of automation on top of your own KMS and not worry that the SaaS company is going to expire data on your schedule. So this is great for customers. Often they demand this. But for the SaaS, this can really unlock new levels of growth. We've heard a little bit about enterprise readiness really expanding the TAM. We can see examples of this by looking at companies like Box. In 2016, they launched KeySafe. That's their EKM. They call it KeySafe. They also got FedRAMP certified that year. They joined a working group called CloudSmart that the US government launched to figure out how the government can start adopting SaaS. They too are being pulled to be using cloud SaaS. And a few years after that, Box secured a contract with the General Services Administration. So that's 12,000 federal workers using Box for file sharing. We can see this even more recently. Airtable, they opened their European headquarters in 2022. They announced a slew of governance features in 2023, one of which was EKM. And recently have shared that the majority of their new registrations are coming from outside the US. And so a lot of these are in territories where there are laws and much more strict regulation around data and data security and handling. You're familiar with Europe, but this is also true in places like India. South Korea is actually, the government directly audits companies around their data handling. And so this has been a big growth trajectory for them. These are big SaaS companies. You probably recognize most of these names. They all have an EKM feature. But not just SaaS companies. At WorkOS, we use this company called Doppler. They manage secrets for applications to secure our application developer infrastructure. Certainly, this is very sensitive information. If a secret were to be leaked, that could affect us, WorkOS. They are encrypting these secrets in their own infrastructure, but they extend that to their customers, and they let their customers provide a key, a KMS system. So if we want to own the key that Doppler is using to encrypt our own secrets, that's a feature, and they're fairly early stage. So starting to see this capability even in mission-critical SaaS startups. And of course, heard about this already with AI. You know, a lot of AI is valuable if it has access to a lot of data on day one when you deploy that. And you know, enterprises are still kind of scrambling to figure out how do we have governance to this. I think we're kind of in a moment similar to the early cloud SaaS where they had to figure out IAM and SCIM. Now we're trying to figure out how do we give AI products the data they need, but still retain control over that data. We already heard about kind of approaches with fine-grained auth, but data tokenization is also emerging as a way to kind of selectively redact information, but not lose that from a training set in AI. And how do you tokenize data? Well, you encrypt it, and you use keys to manage that encryption. So I think that EKM is really poised to solve a big part of this problem. We're building this. We will launch EKM in 2025. If you're thinking about this, I'd love to talk to you. We're going to be opening up a preview access to select customers. So love chatting about all things encryption. I'll be here, but happy to take some questions now.
Do you see EKMs being kind of like standardized so people would use similar components instead of like building their own kind of moving forward? Because you've mentioned a few examples, they all came up with their own version of like BYOK basically, but yeah.
Yeah, I don't think it'll be standardized into like some IEEE something protocol, but the technique is very consistent. When you do go and look at how all these companies are implementing it, they're kind of doing it in the same way where they are generating intermediary keys, they're using customer keys to encrypt keys, and then those keys to encrypt data. And so I think like, yes, in terms of like best practices and how you build this, and how you build it at scale as well. You can imagine that you do need to be worried about kind of the efficiency of your EKM system because a lot of times you need to decrypt data in real time for it to be used in reaction to a customer action in an application. And so, yes, I do think that the kind of techniques and approaches are becoming pretty comparable.
How do I know when I should start thinking about implementing something like EKM for my own company?
There's kind of a staged approach. I think you'll get requests for BYOK. That's kind of typical sometimes in contracts themselves. And so how you implement kind of BYOK, you could try to kind of hack something together to kind of address a single customer or start thinking a little bit more long-term in terms of how are we going to address kind of data encryption holistically. I think the second piece is that it's likely you need to be implementing some type of encryption around specific pieces of data already. So if you participate in like the ACH Nacho network, you need to be encrypting account numbers and routing numbers. If you have card data, PCI. And so that's also going to drive you to start adopting encryption into your application layer. And so anytime you start to kind of see that, yes, maybe the first pass an app goes directly to a KMS, but very quickly that complexity grows and is a big reason to start to build some of the building blocks in it early on.
How often are they paired with the ability to be able to get the encrypted data out so that the customer could use it without trusting the service any longer versus just the ability to revoke the service's access to the data?
Yeah, there are some use cases where, and again, this is mostly in a fintech, where you do need tokens of your own data to interact with different networks. And so that's a fairly common use case where you do actually want to pull that encrypted token back out of the service, and you'll need to be exposing that through the API. But from the kind of like deletion, expiration, or protection, It's pretty acceptable that cryptographic deletion is just remove the key. And so in the majority of cases, customers are fine just retaining control over their KMS. All right, well, we got one more great talk coming up. I won't take any more of your time. Thank you all.
Let's go.